4 down, that's not bad. 10 to go.
You said no coalescing is 5 minutes.
Oh, if that. If that. It's probably shorter than that. It's 14, man, it's easy.
You're not gonna-
Don't know, don't ask me, nothing to do with me. You've paid your money, you take your choices.
Yeah. Let's go for it.
Nil coalescing, anybody?
Yeah.
2, nil coalescing?
Sure.
3, 4, fine, okay. Let's try and find nil coalescing in this little tiny screen thing. There it is. Okay, nil coalescing. So, I want to make this clear up front. I do think Swift optionality is very good. It keeps your code safe. It keeps your apps safe. It keeps your code from crashing. It's brilliant. But if you can get rid of them, get rid of them. Go for hard values rather than optional values every time. They make your code harder to read and write and maintain. So we can get a UI label rather than an optional UI label, go for it every time. Nil coalescing only really has one job, which is there to remove one level of optionality for you automatically, which is great. And it really comes into its own with try question mark. So for example, let name string, optional string, Taylor. Print the name. Now that's going to print out optional Taylor, because it's optional, which no one wants. If you'd written instead, let unwrap name, name question mark, that's the nil coalescing operator, followed by anon, and print unwrap name, it will print Taylor, not optional Taylor, which is way better. What it's doing is saying, if this thing is optional and has a value, unwrap it and use it. If it has not got a value, use this default instead. So it ensures there's always going to be a value. Unwrapped name is no longer an optional string, it's a hard, real string. That's what it does. Very simple. And I'll walk you through some code examples so you can see it yourself. So, you saw already what was the example. It was like let name string equals Taylor, right? Equals Taylor, and then print name. Optional Taylor, bad. We don't want that. Let unwrap name equals name, otherwise anonymous. And now print unwrap name. Taylor. So let's use the default or unwrap this. It's guaranteed to have a value now. Have you looked at unwrapped value? Here. It's not string question mark, it's a real string. It's removed the optionality. It's very, very helpful to have. Now, of course, you don't need this temporary thing in here. You can just put in here directly like that, name or anonymous, whatever works well for you. But it's really, really great whenever you're calling functions that will return optionals. For example, you might have something like func returns optional string, and then we'll just do return nil for now. Then here we'll do let returned name equals returns optional string, otherwise anonymous, and print return name. So you're guaranteed to have a value. This is so far straightforward. Whereas more interesting is you think of things that will return optionals, like try question mark I said already. For example, if you had do let save text equals try string, try space string, contents of file save.txt, then print, why have you lost the formatting Swift? Print save text, catch, print failed to load save.txt. So if the file exists, it will be loaded and put into save text and printed out. Otherwise, it will print out failed to load. Easy enough. Now in practice, if you had some saved text you want to load and use, you probably want to have a default value as well. You just say something like this. Let save text string, save text equals that, otherwise save text equals hello world. So attempt to load the saved one and print it out, otherwise load the default value. That's easy enough. That's what the kind of code you'd write without nil coalescing. But nil coalescing plus try question mark works together beautifully, because you can take most of this code and get rid of it. You can say this instead. I'll leave that there so you can see the comparison. Let save text equals try string contents of file saved txt, like that. Otherwise, hello world. Boom. Print save text. This is turning the throwing function into a non-throwing function realistically that will return optional, a value, or nil, which is perfect for nil coalescing. So you can just have question mark, the default value, taking all this code up here to just that. Significantly shorter.
What do you mean by label statements?
Well, that's kind of the point, isn't it? That's why you're going to learn when you get into that topic.
Guard, is it the normal guard or is it like tricks or something?
Only one way to find out, man. You know what I'm going to say? I'm going to say guard's awesome, right? Okay, because it's all awesome. It's here for a reason. You know, if it was like simple, it wouldn't be called Advanced Swift. It would be called Beginner Swift. So. Generics? Oh, right. I love generics. Generics, awesome. I'm totally psyched about Swift. You know? Right, so. Yeah, absolutely. There is a massive, massive pattern here. Let's try and find generics in this miniature screen thing they've got on my laptop. These references, closures, lazy loading. Oh, it's way down, like number 11, right, okay. Tuples, and therefore, shortly, generics. Brilliant. All right, generics. Let's do this. Okay. Which of you are using generics today? 3 of you. I am disappointed. Trick question. You're all using generics, unless you're writing super trivial Swift code, because string, int, Pokemon, that's generic, right there. Doesn't realize it because it's got fancy syntactic sugar, but string in brackets is really array Pulp Fiction brackets string. Now, both work, but one is syntactic sugar for the other. And what it means is whenever you see these Pulp Fiction brackets, that's a sign. There's generics here. Be on the guard. So, they are extremely easy to use. Like I said, array of strings. Generic right there. But they are harder to create. So the question is, why bother? If they're so hard to create, where's the point? And the answer is because you can constrain things beautifully. You can do really, really powerful generic saying, generic here, but only if this is the case. I'm going to walk you through how generics work in Swift 3.0. They have got better in Swift 3.1. I'm not doing that today, I'm afraid. But there's more power. Again, that article, hackerswift.com/Swift3-1 has the new generic explanations in there as well. It does even more, is the short version. So that's going to walk through what generics do with some trivial examples to get you started. I like trivial examples. So mirror displays, zap all that, and zap that too. That's the article there. You can look down and see new generics. Lovely. Anyway, right, generics then. So we're going to go ahead and design a very simple function, the most trivial function I can imagine. we're going to say func inspect string, value string, print received string with the value value. We can now do in here inspect string haters gonna hate, and that'll work. So now let's create the same function, but this time one for integers. We want to have func inspect int value int. Great. Print received int with the value value. Inspect int 42. And now let's create another one to do doubles. Nah, I'm bored already, right? This is tedious code. No one wants to write this code. What you want to do is say inspect anything. I don't care what type it is. So you could write a function that's generic using those Pulp Fiction brackets. You'd say inspect and write a type in here. I'm going to write some type. And value will also be some type. And now inside this thing, you can add more code to work on that generic thing. So I can write in here, for example, received interpolation type of value with the value value. And I'll do inspect, hate's going to hate, inspect 42. Now, what's happening here is this is a placeholder. A unknown data type called some type will be used. I don't know what it is. You don't know what it is. No one knows what it's going to be. At some point it'll be used in the future. And I'll call it some type. I can use that inside the function. I can say the parameter will be of some type as well, of the same type, whatever that is. And it's conventional to use T, type. If you have more than one, T and U, or TUV. If you are feeling really elite, TUV, WXY, Z. I mean, as you like, it doesn't actually matter. It's just a placeholder name for that type to be used elsewhere. Now, you might be wondering, what does generics actually bring to this thing, right? It doesn't actually bring anything at this point. And the answer is, generics are useful because they do stand for a type. So we could say something like this. You know, what's the difference between this and doing inspect value any? Oops. Answer is nothing at all. At this point, it works fine. But what we can do now is say this. If we had inspect t value t, we could do value 1 t, value 2 t, which you couldn't do with any. If you had any here and any here, it would mean that value 1 could be an integer, value 2 could be a string. Different types. Using TT, they must both be the same thing. Whatever T is, int or string or Pokemon or gremlin, who knows what, they're the same. It's a real thing. So it lets you limit things very, very easily. Now, we don't know at the time of writing this method, this function, sorry, what T is going to be. But Swift knows at compile time who's calling it and how it's being called. So it can look up and make sure it's all completely valid, which is helpful because you can limit these things. You could say, for example, func square t must be some sort of integer. Value t, return value times value, like that. And Swift will ensure it'll multiply it. Now it's going to complain a little bit because you can't multiply integers, believe it or not, in Swift. And that's a problem because obviously we want to multiply integers. The issue is that you get multiple kinds of integers. You get uints, you get regular ints, you get int8s, you get uint8s, you get uint64s, there's loads and loads and loads. And Swift has no sensible way of grouping them together. So you have to be careful what you do. In this particular case, integer will work because it's multiplying itself. So we could just write returns int, t. That'd be fine. But if we had something else like a float or a double, it wouldn't know what to do. It wouldn't handle it. There's no way of saying some sort of number. There is no all-encompassing way of saying all ints and all floats and all doubles at once. We can make one. And it's really easy to make if you want to. You can say protocol numeric. And all we're doing is a protocol. We're defining this thing must exist. So to conform to numeric, we're saying there must be a function called star, which takes LHS self, RHS self, and returns a self. So as long as things have that operator, they'll work. Float has that, double has that, and int has that. So we can actually now say extension float colon numeric, extension double colon numeric, extension int colon numeric, making those three things conform to the numeric protocol which is defined. And now we can write t numeric. So we can square ints and floats and typos and extension. We can square ints, we can square floats, we can square doubles. So square 42, square 5.56, whatever. They'll all work, which is cool. So that's generics. They're not really that hard, and they are clever because of the way you can constrain them to types or protocols that you've made yourself. But creating them is slightly harder. You have to think ahead of time how to create them. And the example I normally give is one of a deque, D-E-Q-U-E. This is a double-ended queue. You'll see it in like the STL, if you're a C++ developer. But it's not very hard to do. We can create a custom data type called a deque, which is generic, very easily. We'd say struct deque is generic with type T. Then give it some methods. Now, a double-ended queue is something you can push to and pop to from the front, or push to and pop to from the back. Either end is a queue. You can't go from the middle, but either side's fine. So we could say var array is an array of t, equals. So that's our storage. We're going to store things in there, whatever happens to be, numbers or strings or whatever. And then create some methods. Mutating func pushback obj t. And we'll do array.append obj. Then mutating func push front obj t. Array.insert obj at 0. Oops. Or pop back, take one from the end. Mutating func pop back returns optional t, because it might not exist. Return array.pop last. Then mutating func pop front returns optional t. And we'll just do array.pop front. Oh, no, we won't. There's a pop last, but not a pop front. Thanks, Apple. Slightly more work. If array.isEmpty, return nil. Else, return array.remove first, which exists, but pop first does not, sadly. You can go ahead and use it. That's our custom data type now. We can do var test deque equals a deque of ints. And do test deque dot pushback 5, test deque dot push front 2, test deque dot push front 1, and then test deque dot pop back. It's flexible. It's generic, which is good. You can also work with Cocoa data types from Foundation. And if you've read any of my books, you'll know I have a personal pet favorite data type in Foundation, which is very rarely used, but it's quite wonderful. It's called NS counted set. I love it. And I'll show you why. But it's not generic, annoyingly. So I'll scrap all this code. We can wrap NS counted set in our custom counted set and make it generic, filling in the gaps of where counted set ought to be, and probably will be at some point in Swift 4 or Swift 5. I'll probably catch up slowly. We can say struct custom counted set t any. We don't care what it's going to be. We'll do let internal set equals NS counted set. This thing is a set you can add to and remove. So we'll write mutating func add obj t, obj t, hello. There we go. And we'll do internal set dot add obj. Then mutating func remove obj t, internal set dot remove obj. And the power of counted set is that it looks like an array and a set at the same time. It's very clever. It works like a set. Items can be in there uniquely, only once at a time, rather than three of the same thing. But when you add an item more than once, it keeps track of how many times you added it or removed it. So you can say add A, add A, add A, add B, and say how many A's. It'll go, there's 3 A's. It counts them for you. It's brilliant. So we can do func count for obj t returns int, and return internal set dot count for obj, like that. So now we can write some code to use this generic. We can say var counted set equals custom counted set of strings counted set dot add hello. Hello, hello, hello. And we'll do in here also goodbye. We can ask it counted set dot count for hello. 4. So you get all the power of NS counted set, which is brilliant. I love it. With a typo, I put coin in it both times. I'm a bad typer. Both times without realizing, I've also got a slight twitch with my thing. So all it does is basically wrap NS counted set with type safety, because by default it takes ID, instance type. It takes nothing at all in the Objective-C. It's just any kind of thing you want, which is useless. Wrapping it in a protective layer is good. I do think they'll probably fix that in the future, but we'll see. So that is generics. Let's go ahead and cross it off the list.
So why would you want to wrap?
Closures? Cool. Closures are good. Closures are number 5.
They're awesome, right?
They are indeed thoroughly awesome. Pop. Values in reference. Errors. Closures. Like it. Okay. Closures. Closures are very interesting in Swift, unsurprisingly. In fact, they are endemic in Swift. They're everywhere. So, let's start something real simple again. What is a closure? I've tried to define it for you here. It is a block of code that can be passed around and stored like a variable, which also has the ability to capture any values it uses. And this is the part that foxes some people. We'll come back to it shortly. Capturing, what does it really mean? And I said they are used everywhere in Swift. They're really endemic. They're popular, which is great. And they also have the special shorthand syntax, which we've seen briefly already, all $0, $1 stuff. Plus, they have a good habit of looking totally messy. You can really get a bit blind to what this thing's trying to do sometimes. That's why I try and work from simple to hard, so at least you can stop somewhere and be useful. And the magic of Swift is that it blurs the line between functions and methods and operators and closures beautifully for great benefit. And I know you probably think, closures? I know closures. You will learn something new in the next 10 minutes, I guarantee it, because they're really remarkable little beasts, closures. Again, we're going to start easy, simple, clear. So let's zap all this code and kick off. We're going to create a simple closure. Let greetPerson equals open brace, print hello there. That's a closure called greetPerson, which you can then call. You can say greetPerson. Hello there. Now, because they are first class data types, like integers, like strings, and like others, you can copy them and you can use them as parameters to other functions and so forth. So we could say, let greetCopy equals greetPerson, and then call greetCopy. That's fine.
Is it a copy?
Well, it's clearly a copy. Is it pointing at the same data types we're asking? The same data?
Is it pointing at the same data?
Yes. Closures, there are only 2 reference types in Swift. The rest are value types. One is classes and objects. One is closures. And if we have time, I might show you an example of how that will completely screw you up if you're not careful with closures. Because if you copy a closure, they both point at the same values, which is really bizarre. So at this point, you're thinking, why is a closure even needed? I can just write functions for this, right? This is ridiculous, and fair enough. Fine, of course. But what if you want to call the code after 5 seconds? Or only if some condition is true, like we have with assert. Having a closure means you can store it away, wait 5 seconds, then call it very easily. And you can do this. You can sort of modify this to get busier and busier and busier, and store it away and call it as needed. So we could say something like this. Let greetPerson, ugly syntax alert, I think personally, but there you go, name string in. What that means is this closure now accepts a parameter called name. So we could write hello name. And here, we're now calling it, would say greetPerson Taylor. That. So we must now pass in a parameter. You can't just call greetPerson by itself. And it's also where you specify a capture list if you have one. So you might have something like this. If you were in a, say, a UI view or controller or something like that, you'd have unowned self in. It won't work here in a playground, but you see what I'm saying. The capture lists go here before the in statement kick off. Now, passing parameters using closures to functions is complicated. Partly because you can just go blind to all the colons and all the arrows and all the parentheses, and it looks hard to read, like just line noise to your eyes. And second, the calling convention varies depending on what you're trying to do. So you've got to be careful. So we had some sort of closure in here. We had like, func run some closure here. And we'll make this thing accept a closure. And the closure must be something that accepts a string and returns void, like that. And we can call closure with, I don't know, Taylor or something. We can use that with our greetPerson closure. So like this, let greetPerson equals name string in, print hello name. And I can do run some closure, greetPerson. So there's always underscores and colons and parentheses and arrows and stuff. But what it's telling us is that this function here accepts a closure, some code to run, and that closure must accept a string and return void. So that's the absolute basics of closures. Let's look at how it captures stuff, because capturing is cunning. It does not copy. It sounds like it copies data. It does not copy data. It captures data. So if we add func test capture, returns a closure, it returns void. Even a simple like that, you're sort of going, well, parentheses everywhere, arrows, that's fine. We're going to add a simple thing. Var counter equals 0. Then we'll return a closure. Return counter plus equals 1. Print counter is now counter. Like that. Watch this. If we did let greet person equals test capture, we'll call greet person, greet person, greet person. 1, 2, 3. This thing, counter, that was inside the test capture function was captured by the closure. It's got a reference to it inside itself, which you can modify and modify and modify and store. It looks like it's going to go out of scope. Like here, counter stops existing. But it's inside the closure and referenced there, so we can call it back and call it back and call it back. But then try this. Let greet copy equals greet person. Greet copy. Copy, copy. Greet person. You'll see now, doing well, it counts all up to 7. Because the copy, the reference type, they're both pointing to the same data, to the same captured value, and they're both modifying it now, adding one, adding one, adding one to the same value. So it's a reference type which can really, really hurt your head. It's important to be careful when you use these things, because if you are copying them, they do point to the same data, so be very careful with that. Now, before I want to get on to the advanced stuff, I want to show you just briefly shorthand syntax. I was using it sort of like willy-nilly earlier, which isn't fair on you. I want to break down what it's really doing, because you can kind of stop at any point and use whichever syntax you like. So let's have an example. Let's do it again. Let names equals, actually I'll copy and paste it, shouldn't I? Michael Jackson, Taylor Swift, Michael Caine, Adele Adkins, and Michael Jordan. Michael Jordan. There we go. We can filter this to get all the things that have the prefix Michael in there. And the longest way you can write this, a sort of official, purist, Swift way, original, not shorthand at all way, is do this. Let result 1 equals names.filter, parens, brace, name string, returns bool, in. Then, if name.has prefix, Michael, return true. Else, return false. And then end the method and print result 1. There you go. So that will go through every item, assign it to a variable with name string, which returns bool, checks has Michael or not, and returns true or false. So that's simple enough. Now Swift knows that the closure being passed the filter must accept a string and must return a bool. So you don't need to have this specific value here. You're just saying name in. It must return a bool. It must be a string. Delete it, take it out. We can also return the result of has prefix directly. We just do return name has prefix, like that. We can also use trailing closure syntax. Delete these parens. And as our closure has only one expression, one line, that must be the one that returns the answer to the question. Should it be in there or not? So you can hit return. Must be that one. And many people stop here. That's enough. Yeah, that's good enough, right? It's clear, you can see what's going on. I'm fine with that. But the next step, the final step, is what's called shorthand syntax, where you have $0, $1, $2, and so forth to represent the values coming into your closure. So we have name here. We can, instead of that, use $0. We can zap that entirely and say $0 has prefix Michael, and it means the same thing. At this point, people go, okay, it's short enough, it's one line of code. Like that. Now, you notice I removed the name in part because you cannot mix the two. You cannot say here, name in, and then use $0. Swift will complain and won't be your friend anymore, like that. You have to choose. Use name or use shorthand syntax, whatever works to you. And that's it. So you have to admit, it's a massive improvement in terms of length of code. Is it more readable? That's your problem to figure out for you. I prefer to use it personally. I think if we all use it, it'll all be readable, I'm sure. So that is shorthand syntax. I now want to look at the way Swift blurs the lines between functions and methods and operators and closures, because this is one of the most advanced and powerful features of Swift, I think, realistically, in terms of impressiveness. So if you use Foundation, which of course most of you will do, you can have a code like this. Let input equals my favorite album is Fearless. And you can say input.contains album. Does this string contain the word album? Yes, true, easy. Now, Swift arrays also have a contains method, right? And there's one way to specify an element directly, like Taylor or Paul or Adele, is this thing in the array. There's another one that accepts a closure. So like if you look here, 1, 2, 3, dot contains a closure. You use where followed by a closure, some code. So if I had in here, Taylor, Paul, Adele, dot contains, you'll see the closure accepts a string and returns true or false. Does this contain, contains where, some closure, matching code? We can combine the two together. We can write an array of words. Let words equals 1989, Fearless, red. Then say words.contains where, brace yourself, input.contains. True. So using the string contains as the closure to the array contains. The last line is key. It will call its closure, input.contains, this part here, it'll call that once for every element in the array. It'll say, input contains, find me, input contains 1989, false. Input contains Fearless, true. Input contains red, false. So it'll now say, do any of those words in the array appear in that string? I said already, this is commonly used also, this blurry closure thing with reducing. I showed you already, let numbers equals 1, 2, 3, 4, 5. Let sum equals numbers, but reduce 0 plus, because plus, of course, happens to be a function that takes one value and another value and adds them together. So it works perfectly well. So Swift doesn't care whether it's an operator or a function or a method or something else. It'll just figure it out. It's really, really flexible, which is great. There are some more advanced closures that you will meet that are called escaping closures. And you saw it briefly with we did the function composition. Remember that? We did the triple publication bracket thing. We used at escaping. Hadn't explained why. Now you can find out why. At escaping. What it means is that, so closures are reference types, right? They have a reference count attached to them, it means. If you are aware of automatic reference counting, ARC, that's what it means. When a closure comes in, it's a reference, it gets owned, add 1 to the reference count. When it goes away, you minus 1. That's how it works. It knows how to free the closure at the right time. If Swift knows the closure will not be used later on by surprise, it's considered a non-escaping closure. It'll be used straight away and forgotten about. It does not do retain release. It doesn't need to. Whereas, if you say, please run this thing in 5 seconds, it has to retain the closure, has to perform memory operation to keep it safe, because it might be destroyed in the next 5 seconds, and that will script your code. So by default, Swift considers all closures to be non-escaping. They must be used immediately. So let's do an example. I'm going to make a queue of closures. This is an array of closures that accept no parameters and return void, and it's empty. And I have a function here, queue closure. Takes a closure, which of course takes no parameters and returns void. And all it's going to do is append to the queued closures. It'll append to that array. It'll say queued closures dot append closure. So we can now write queue closure here. I'm going to put in here print running closure 1. And then 2 and 3. So it creates an array of closures and queues them up. And of course, ultimately, you want some sort of execute queued closures. So you have something like, func execute queued closures for closure in queued closures, closure. Queue them up, wait a period of time, run them all. Now Swift's complaining. It is not letting us do it. This is escaping. This is not being used immediately. I have to do extra work to use this closure. It is not safe to use a non-escaping closure here. It must be an escaping closure. It even fixed it for you, I think. Yeah. Boom. Mark that as escaping. I will use this later on, and you're away. Now, if you think about it, are you UI kit people or app kit people? UI kit? Yeah. Okay, fine. When you did like UI view, animate with duration, completion, that completion is an escaping closure. Because it will happen in 2 seconds, 3 seconds, whatever it is. When the animation finally finishes, then run the closure. So it must retain the closure, must add an arc +1 to it for later on. That's at escaping.
If the compiler knows it needs to be escaping, why not do it implicitly?
I don't think it wants to hide the performance impact from you, I think is the key here. It used to be, in fact, before Swift 3, it was the other way around. It was you had an at non-escaping attribute.
But either way, it's verbose.
Swift is verbose. It is verbose. I mean, the whole try keyword, try doesn't need to be there. You've got do catch already, why have try? Because it makes it clear that's the line it might throw. It's verbose, and I'm cool with that. I'm used to it.
Yeah, the at sign is already a signal that this is outside of the normal language syntax.
Yeah, I know. So Swift considers them escaping, so you must mark them escaping as escaping. And you've also already seen another one, at auto closure, which is very cool, and it's used in assert I showed you briefly. I want to show you actually how it really works here. If I do func print test result, takes a closure that returns void. Oops, hello, returns void. And here I'm going to say print before, then call my result closure, then print after. And to call that, I'd say print test, open brace, print hello, close brace, end parens. And you'll see before, hello, after. This code is not run straight away. It's passed in here to be run when we're ready for it. So you'll see before first, then run the closure, print hello, then after. And that's basically how closures work. But you can also use the auto closure keyword, like this. You can say result at auto closure, that. And now you can remove the braces. It's the same thing. Now, this obviously is a very trivial behavior. We've deleted some braces, which is quite useless. But in terms of assert, that's important, because it means this code is not run immediately. Your assertion, run this really slow method, is not run immediately. It's run when it needs to be run, only when debugging is enabled, because you're plugging to Xcode. I would say Apple does warn against you doing this auto closure, because it can really confuse people. It looks like this line here, it looks like we're calling print and passing the return value of print into the function. It looks like, so be careful with it. But again, I showed this already, I want to show it to you again, because hopefully as you're learning more and more, you can read more of this code. Check this out again. Public static func and. Remember this one? We had LHS bool RHS at auto closure. Throws bool. And then it's all rethrows bool, like that. And it was return LHS ternary try RHS false. I showed this before. You now know what rethrows means. Don't force me to use try catch unless I really need to. But you now also know what at auto closure does. This thing here. Why is it an auto closure, do you think? This is logical and. A and B. To bail early, yes. So what we're seeing here is called bailing early, aka short circuit evaluation, right? If A and B means if A is true and B is true, do something, right? But if A is false, there's no point evaluating B. We've bailed that already, it's false. The thing will be false and true at best. It will not be true. There's no point going further. So what it's saying is, if this is true, try looking at the right-hand side. Otherwise, bail out immediately. It's short circuit evaluation. All done using auto closure. It's very cool.
Without auto closure, that really wouldn't be possible. It would be more dangerous.
Yes, correct.
Because right-hand side would be evaluated regardless.
Pretty much, yeah. Which you wouldn't want.
There's other ways of implementing that in other languages.
There are, of course.
And is a method, right?
Yeah, of course there are. And what I like about it is it's one line of code showing multiple bits of Swift syntax at the same time. You can see it combining into one beautiful whole. And that is closures. It wasn't so hard, was it, you see? Closures are awesome. Let's go back to the display. I'll mark off closures being done. There we go, closures are green. Look at that, we've still got like 90 minutes to go, ages.